Hello friends, this is Sushrut Tendulkar and welcome to my YouTube channel. This is a fourth video in the series Introduction to Natural Language Processing. In this video, we're going to learn what is language modeling, types of language modeling, and the intuition behind the Ngram language models. We'll then look into some of the challenges associated with Ngram language models and possible solutions for that. Let's get started. What is language modeling? Language modeling simply is the task of predicting what word comes next given some sequence of words. For example, if you have the sentence I love reading dash, what would you fill? There can be many options. I love reading books. I love reading news. I love reading mind, etc. So, the task for a language model is to find the best fitting word for the given sentence. To give a mathematical equation, given a sequence of words, say x1, x2 till xt, compute the probability distribution of next word x of t plus 1. That is, probability of x of t plus 1 given x of t minus 1 up till x of 1. What is a language model? Language model is a system that assigns probability to a piece of text. If there is some text x1, x2 till xt, then probability of text according to the language model is probability of x1 till x of t equals probability of x of 1 times probability of x of 2 given x of 1 times probability of x of t given x of t minus 1 till x of 1. So basically what we are saying here is that we are multiplying the probabilities of each word given all the previous words. This can be represented as, and this is going to be the output of a language model. Let's see some of the types of language model. There are primarily two types of language models. One, statistical language models. These models use traditional statistical techniques like Ngrams, hidden Markov models, and certain linguistic rules to learn probability distribution of words. Second, neural language models. These are new players in the NLP town and have surpassed the statistical language models in their effectiveness. They use different kinds of neural networks to model the language. Now let's understand Ngrams. What is Ngram? Ngram is a continuous sequence of n items from a given sample of text or speech, or simply a chunk of n consecutive words. Let's take a sample sentence. Thank you so much for your help. For this sentence, let's see how unigrams look like. So, unigram is collection of words. Thank, you, so, etc. Bigrams are collection of two words from the sentence. Thank you, so much, etc. Similarly, we can compute or calculate trigrams and fourgrams accordingly. What is the key idea behind Ngram language model? Simply collect statistics about how frequent different ngrams are and use these to predict the next words. We want to be able to predict the next words based on the count of different ngrams in a given corpus of text. How to calculate ngram probabilities? By counting different ngrams in some large corpus of text. If you look at the formula, it's nothing but count of the n gram divided by the count of n minus 1 gram. Let's see the example of a 5 gram language model. We'll take a sample sentence to learn a language model. Let our sentence be, "Thank you for your dash." We have to train a language model that can guess the word with the highest probability, which can be filled here. We can do that with this formula. Probability of any word W given "thank you for" equals count of "thank you for your W" divided by count of "thank you for your." We have to repeat this for every word W in the vocabulary so that we'll be able to predict the next possible word based on the probability. Suppose in our corpus, "thank you for" appeared 1000 times and "thank you for your help" occurred 500 times. Then the probability of help given "thank you for your" equals 500 by 1000 equals 0.5. Similarly, if "thank you for your book" occurred 200 times, then the probability of book given "thank you for your" equals 200 by 1000 equals 0.2. Similarly, we can compute the probabilities of each of the words in a vocabulary. Once that is done, we have to move the window of 5 gram model and start computing the probabilities for the next set of words. In our case, we move the window from "thank you for your help" to "you for your help dash." Now you can imagine how much computation and storage is needed to store all these combinations. We can generate text with Ngrams, and that's the key idea of language models. Let's see how to do that. We'll again use a 5 gram language model for the purpose of this exercise, which means given a 4 gram, we should predict the next word. From the earlier exercise, we have calculated the probability for every word corresponding to this 4 gram. From this list of words, we pick up the word with maximum probability. So, we choose the word "help", which has maximum probability of 0.56. We add the word "help" to 5 gram and repeat this exercise of finding the probabilities of words for the new 5 gram. From the new list of words, we pick the word with maximum probability. We add the word and continue this exercise. Well, that's how we generate the text using statistical Ngram model. There are few challenges associated with Ngram language models. Let's see them. We have the equation for finding the probabilities for words given the Ngram. Let's look at the numerator of the equation. What if the numerator never occurred in the corpus? Then the W will have the probability as 0. What is the solution for this? Add a small delta value to the count for every word W in the vocabulary so that every word will have some minute probability and will not be 0. This technique is called smoothing. What about the denominator? What if denominator never occurred in the corpus? Then it's impossible to calculate the probability for any word W because division by 0 is undefined. What is the solution for this? For our example, just consider "you for your" instead of "thank you for your." Basically, you would reduce number of words and make it a smaller Ngram. And this technique is called back off. So, those are the two key challenges with Ngram language modeling and possible solutions for that. Let's recap what we learned here. First, we learned what is language model and types of language models. We looked into Ngram language model and a way to generate text using Ngram language models. And finally, we saw some of the challenges with Ngram models and possible solution for that. Well, that's it for this tutorial. Thank you so much for watching. Keep learning. Bye bye.